Okay, greetings to all. This is Dr. M. Shakti Mohan, Associate Professor. So, in today's video, we are going to discuss about the combinational circuit design, in particular about half subtractor and full subtractor. Okay, so the basics of combinational circuit, and then how to design the half and full subtractor. We'll discuss one by one. So, we'll go into the video. Okay. So before entering to the video, so first of all, we have to discuss about the subtraction rule. Okay, that is very, very important to design the subtractor. And also, we must know about subtractor is a combinational logic circuit. So the technical definition of combinational logic circuit is all the logic gates are combined together to perform a specific task with the help of some set of input variables, and in the output line it would deliver some set of output variables also. The major point in the combinational logic circuit is without a memory element. That is what the major point. Since it doesn't have a memory element, the output is time dependent on the present input, not by the previous inputs, right? So that is what the definition of combinational logic circuit. So next we'll discuss into the subtractor design. So before entering to the subtraction, so first of all we know about the subtractor rule, right? Okay, we'll see. Wait. Okay, so the subtractor rule is very simple. So we have two inputs, right? That is A and B, and there are two outputs in the subtractor, that is difference and borrow, right? Okay, so if I minus, that is 0 minus 0 now, the difference is 0, there is no borrow also, and 0 minus 1, so we'll see the result later, and 1 minus 0 means very simple, 1 minus 0 is equal to the difference is 0 and there is no borrow, and 1 minus 1 in a also very easy, 1 minus 1 is equal to the difference is 0 and there is no borrow, right? So now we just come into 0 minus 1. Why I am telling this as a special now, because many students did mistake in this, so that is why I'm just telling this as a last one. So 0 minus 1 means actually the result is 11. Okay, so that means the difference is 1 and borrow is 1. So how the result will be there means it is very simple. So 0 minus 1. Okay, so how we will subtract this now? So with the help of borrowing to the neighboring bits. Okay, so actually there is no borrow, there is no neighboring bits to take the borrow, but even though we have to take the borrow, right? So that is what the subtraction rule, general rule, right? So 0, actually we have a 0, and if you take a borrow means so the 0 will be as 10. Okay, so after getting the borrow, okay, so 10 minus 1 is equal to actually 1. So how 10 minus 1 is equal to 1 na? We know that 1 plus 1 is equal to 10. This is the basic addition rule, right? So that means 1 is equal to 10 minus 1. So 10 minus 1 is equal to 1. Okay, if you convert this 1 into that say na, so 10 minus 1 is equal to 1, right? So this is how 0 minus 1 அப்படிங்கிறதுல, so we just taken borrow now. So after taking the borrow, so the result will be 1, that is the difference will be 1, and borrow also 1. Okay, so that means 0 minus 1 is equal to 1, and 1 will be the answer, right? So this is what the subtraction rule. With the help of this rule only we are going to design the half subtractor and full subtractor. Okay, we'll see. Okay, see here, so the same thing will be there. Okay, so these are the subtraction rule, that is 0 minus 0 is equal to 0, 1 minus 0 is equal to 1, and 0 minus 1 is equal to 1, but with borrow 1, right? And 1 minus 1 is equal to 0, right? So first again since we already discussed about the subtractor, half and full order in the previous video, so the same concept, if it is a half subtractor na, so it contains only two inputs, right? So for 2-bit subtraction, we are going to use it for half subtractor. In the same case, if you are going to subtract 3-bit numbers now, so for that we are going to use the full subtractor, right? So that is the case. Okay, so that is the only difference between the half subtractor and full subtractor. So half subtractor having only two inputs and full subtractor having three inputs, right? Okay, so first half subtractor. So the since I already told you whatever the design in the combinational logic circuit, it starts with the block diagram and ends with the logic diagram. So the same part also applicable here. Okay, so the input is A and B and output is difference and borrow. So 0 minus 0 na, so the difference is 0 and borrow also 0. So 0 minus 1 na difference 1 borrow 1, and 1 minus 0 na difference 1 borrow 0, and 1 minus 1 na difference 0 borrow also 0. Okay, so this is what the truth table of half subtractor. Okay, so once you completed the truth table, after that we are going for k-map. So why the k-map is required means because we have to know the difference output equation and borrow output equation to draw the final logic diagram. Okay, so if you want to get the output equation, so the k-map is the only and easiest way. So this is what the k-map for difference, and this is the k-map for borrow. So if you simplify the answer now, for difference we can get the answer as a XOR B, like some result in the half order, and for borrow the result is A bar into B, right? So once you completed the answer, so final the logic diagram will be implemented like this, right? So for XOR gate, I'm just mentioning one XOR gate here, and the difference output is A XOR B, and for the borrow output is this is what B, and this is A bar, so A bar into B, right? So this is how you have to design the half subtractor. So likewise, so the next part is full subtractor, right? So the same concept, one additional input will be there uh, in the half subtractor. That is what full subtractor. So we have A, B, C, or B in. Okay, whatever you can take it, no issue. Okay, and output one the D and B out, B naught. So B naught means borrow out. That is what B naught, right? Okay. So again the truth table. So since it contains a 3-bit input, so 4 to 1 combination will fill it out the truth table. Otherwise, with the help of the simplified method, that is first A column la 4041, and B column la 00110011, and C column la 010101. Likewise, it will be there, right? Okay. So, sir, how to solve the full subtractor na? Very simple. If you taken this input na, first you have to complete this two input with the help of subtraction rule. That is 0 minus 1 is equal to difference 1 borrow 1, and after that the 1 will be subtracted with the 0 na, again 1. So that means, so the final result will be 1, and 1 is the final result. This is how we have to complete this truth table. So you know the procedure. So once you completed the truth table, after that the k-map will be there. So again, if you simplify the k-map now, so this is what the result you can get. So that is the difference A bar B bar C plus A bar B C bar plus A B bar C bar plus A B C, and for B naught that is borrow out A bar into C plus A bar into B plus B into C bar. Okay, so once you got the final result, the final step will be to draw the logic diagram with the help of whatever the gates we need. We just draw the logic gates and just to make the connection, right? So this is what the logic diagram. This is for difference, and this is for borrow, right? Okay. And you know that the difference result is somewhat lengthy. So in order to minimize, so these are the steps. Okay, so if you minimize the difference result now, so you can get A bar XOR B, sorry, A XOR B XOR C will be there. Okay, so and finally you can get this kind of diagram, right? Okay, so for this diagram one more name will be there. So this is the logical diagram, that is a full subtractor logical diagram with the help of two half subtractor. You can see, so this is the part of first half subtractor, and this is the part of second half subtractor. So if you add both the thing, that is the over the thing now, so finally you can get the full subtractor diagram, right? Okay, I hope you understand the today's content. Today we have discussed about the basics of combinational logic cycle, that is the technical definition. And after that we have discussed about the subtractor rule, that is 0 minus 0 0, 0 minus 1 1 1, and 1 minus 0 1, and 1 minus 1 is equal to 1. And after that we have discussed about the design of half subtractor and full subtractor. Okay, thank you.